Hello there. Now we're going to see the second part. We are still in the first chapter, and in the first chapter we are seeing sequences. But now let's go to the second topic. And in the second topic we're going to see the sum and the product of a sequence. And what is that? What is, let's first see this in the most simple case, the sum. What do I mean when I say the sum of a product? Well, let's take this one. For instance, let's suppose we have this sequence 2, 4, 6, 8, 10, and so on. Let's suppose we want to sum some terms of the sequence. Of course, we have to specify how many terms of the sequence are we interested in summing up. For instance, let's sum the first 6 terms of this sequence. And what would it be? 2 plus 4, okay? 1, 2, 3, 4, 5, there is one more. 2 plus 4 plus 6 plus 8 plus 10 plus 12, okay? So that would be the sum. That's right, sum, okay? How are we going to do the sum? Well, let's just add. This is 10, with 10, 20, 30, 42. This is just 42. But we can write this in a different way, okay? And that is what I wanted to teach you in here. What are we going to do in here? We're going to write sigma. That's how we write sigma. Sigma, let's stop for a while. Sigma, it is just a capital S for the Greek alphabet. This is, I'm going to put right in here so no one sees it. This is our capital S, and this is the Greek version of the capital S. This is our lowercase s, and this is the lowercase s, sigma, okay? So sigma can be this one or this one. This is a capital, this is a lowercase. And it is S for summation, for sum. And look what we're going to do in here. Let's take some colors. Now, we're going to write, where are we going to start our summation? We're going to start at the first term. The first term in here, 1. And we're going up to the 6th term. Start point, ending point. And there is something left in here, because this summation, it is regarding which sequence. It is this one, isn't it? Well, therefore, we must put the sequence in here, but everything here, it is in a condensed form. We can't just write this sequence in here. It is not nice. We're going to have to add the general term formula for this sequence. So, and for that, let's bring the general formula. What would be the general formula? An, it is going to be what? This is n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Can you see the relation? Each term, it is the double of its own n. If this is 8 because it is a double of 4, and so an, it is as 2n. Okay? Well, but it also happens that mathematicians, you can put any letter you wish in here. You can put x, y, m, t, s, but usually, okay, usually we just use y in here. I mean I, just I. So this would be just 2i. You could put 2n in here, no problems. And we're going to say this, that I it is this one. So I goes from 1 up to 6. And this is the general formula, the general term formula. And that's it. Now, what should we do? And this means exactly this. How are we going to work with this? We're going to do this, that. And you see 2y, well, we're going to add lots of 2y's. But the first one, we're going to, for the first term, we're going to write 2. We're going to substitute the I by 1. So this is going to be like this. 2 times 1 plus, again, 2, but now I goes to 2. Why? Because after 1 is 2. It's 1, 2, 3, 4, 5, up to 6. We'll just go in a ladder like this. Plus, let's go to the third term. Again, what is the general formula? 2 times something. 2 times what? The I. But now the I, it is 3. Why? Well, because we already use it. I equals 1 and I equals 2. Now I equals 3. Plus. Now, again, what we're going to do in here, oops, this one. Now we're going to again apply the general term. 2 times what? The I, 2i always, but now I, it is equal 4. So put the 4. Again, and again, and again, and again. Again, general term, 2 times I, but I now equals 5, right? Because we already used it 4, now it's times 5. How many terms? 6. We are going to go from I equals 1 up to 6. I equals 5. So there is one more left. Again, general term, 2 times what? Times 6. Okay, and that's it. And this is the value of I. So I equals 1. I equals 2. This is the value of I equals 3. I equals 4. I equals 5. And I equals 6. You see, you're going to repeat this forever, until we reach the maximum value of I, because we are defining here for our summation, I goes from 1 up to 6. Let's apply. I equals 1, 2, 3, 4, 5, 6. And in the end, we have our summation, right? This is 2, this is 4, this is 6, this is 8, this is 10, this is 12. Well, this is 42. And that's how it works. Let's see some exercise. Like I said, as soon as I put the exercise here, my advice would be pause the video, think, write it down, because if you're just watching this video and you're saying, okay, good, very easy, very understandable, no problems, I got it. Of course you got it, because you are just watching the video. To watch the video, it is not very complicated. The difficulty it is when you are on your own. When you just turn off the computer, turn off everything, and you are on your own. It's you, a pencil, an eraser, and a piece of paper. That is when the problem comes, and that's why try to simulate that. Pause the video and think, okay? Because right now you are not thinking. Right now you are just watching. Watching is something, thinking is another thing. And that is why some students, they confuse. They just because they watched the lecture, the class, they think that they understood. They just watch it, they just read. To think, it is something totally new. And just going into this, there is a sentence that says like this: memory, it is a residue of thought. That's very interesting. We just have memory when we think about something, and that is why the students don't retain things into the memory if he doesn't actually do it, if he doesn't think. First, watch it. Second, do it on your own, and that is going to create the thinking process. And after you have some thoughts about it, only then you're going to have the memory. Remember, memory, it is the residue of thought. Okay? But if you just stop in here, you are never going to get here, and you need the memory, right? Okay? Now, okay. Now let's go to the exercise. I already talked too much. And the exercise goes like this. Let's call it A, for instance. This would be our A, right? This would be our first problem. This would be our second problem. And now I'm going to write just that. The summation goes from I equals 2 up to 5. And the general formula for the sequence, it is I squared minus 2i. And equals. I'm not going to say anything else. Now it's up to you. What is the answer? Please pause the video, think through, do whatever you can, and doesn't matter if you can do it. At least you try it. At least you said to yourself, okay, all those ways that I tried, they don't work. And it means that let's see other ways that are going to work. But if you never try, you'll never know that what works and what it doesn't. Okay, now that you had some thoughts about it, let's start. Well, I'm going to put each term of this sequence between parentheses, so it's help us to localize each term. Now I square, okay, so 1 squared minus 2 times 1, right? No, wrong. Why? I starts at 2, not 1. This is a 2. So we're going to do like this. It's 2 squared minus 2 times 2. This is the first term. Plus, this is y, okay? Remember. This is not y, I'm sorry. I keep saying y. This is I. Okay? Oops, I'm sorry. Okay, I fixed that. Okay, no problems. Let's continue. I almost broke, okay, my pants in here. No problems. No one was harmed. Now again, I start at 2. Now next one, 3 squared plus, okay, minus 2 times 3. Now plus. We are going. This is the first term, second term. Let's go to the third one. But the third term, it is I equals 4, right? Okay, let's just give it a thought like this. All this, it is for I equals 2. Why? Because it is telling us I starts at 2. All this, it's I equals 3. And all this, I equals 4. And we're going to have something here. I equals 5 and stop. Right? That. We have a minus in the middle. Okay. I equals 4. 4 squared minus 2 times 4. Again, I equals 5. 5 squared minus 2 times 5. Let's do this one. Okay, and what is that? 4 minus 4, this is a 0. Plus 9 minus 6, this is a 3. 16 minus 8, this is an 8. 25 minus 10, this is 15. Okay, now what do we have? We can add 8 with 3, we get 11. 11 with 15, we get 26, right? So 26, it is the result. Okay, there is no units. Okay, you are just adding numbers. So 26, it is the answer for this one. I just forgot, this is page number 7. Okay, this is number 7.